In lesson 10.8, found on page 419, we're doing a problem-solving lesson. So changing dimensions. How can you use the strategy find a pattern to show how changing dimensions affects area? Jason has created a 3 by 4 inch rectangular design to be made into mouse pads. To manufacture the pads, the dimensions will be multiplied by 2 or 3. How can the area of the design be affected? Use the graphic organizer to help you solve the problem. So the first question is, what do I need to find? I need to find the area of this design. And I need to find how the area of the design will be affected by changing the dimensions. Dimensions are essentially the size, so the dimensions at the moment are 3 and 4. They're the measurements of the figure. What information do I need to use? Well, I need to use those dimensions of the original design and the numbers by which the dimension will be multiplied, which up here is 2 and 3. So I will need to use the dimensions of the original design and the numbers by which the dimensions will be multiplied. The dimensions will be multiplied. Okay, so how will I use this information? I can draw a sketch of each rectangle and calculate the area of each. I always draw a sketch. That helps me so much. Then I can look for patterns in my results. All right. All right, so here we have our sketch with new dimensions. Well, the original dimensions were 3 by 4. But this first set, they multiplied by 2. Remember back here at the top, they're multiplying by 2 or 3. So this first set is being multiplied by 2. This is the original, multiplied by 2, and then the other one we want to figure out is when it's multiplied by 3. So 2 times 3 is 6, 2 times 4 is 8. That's where the 6 and the 8 came from. So here we have 3. 3 times 3 is 9 inches by 3 times 4 is 12 inches. That's where the 9 and the 12 came from. Okay, so area equals base times height, right? Area equals base times height. So the area of the new size of mouse pad, which is 6 by 8 inches, is 6 times 8, which is, 48 inches squared. So here, again, we have area equals base times height. Area equals 9 times 12, which is 108 inches squared. So with the original mouse pad, the area would have been 12 inches squared. The slightly bigger one, twice as big actually, would be 48 inches squared. And then the area of this one that's 3 times bigger is 108 inches squared. Notice that this 12, even though we've multiplied the dimensions by 2, we did not simply multiply the area by 2. 12 times 2 is not 48, it's 24. So when you alter the dimensions, you radically alter the area. And you can't just multiply by 2 to find the area. It doesn't work. The dimensions were multiplied by 2. Same with down here. 3 times 12 would have been 36. We'll notice that the area is actually 108. This one was 48. This was 108. So you can't simply multiply by 3 to get the area. All right, here we go. So when the dimensions are multiplied by 2, the area is multiplied by 4, right? 12 times 4 gets me to 38. When the dimensions are multiplied by 3, the area is multiplied by, what would that be? 9, right? 12 times 9 is 108. So, so the area, like I said, gets radically bigger as you change the dimensions. All right, here we go. Try another problem. A stained glass designer is reducing the dimensions of an earlier design, so making it smaller. Reducing means smaller. The dimensions of the triangle shown will be multiplied by 1/2 or 1/4. So this is the original. They're going to make it half as big or maybe even 1/4 as big. That's quite a bit smaller. So how will the area of the design be affected? Use the graphic organizer to help you solve the problem. All right, what do I need to find? So again, how the area of this triangle, in this case it's, the design for his stained glass window, will be affected by reducing dimensions. Instead of increasing this time, we're making them smaller. Have I been writing 2 M's for all of these? And it's 1. It is 1 M. So sorry. What information do I need to use? So first I need the dimensions of the original triangle, right? So I need the dimensions of, spelling it correctly this time, of the original triangle. And the multipliers, which are 1/2 and 1/4. And the multipliers, in other words, what is going to be multiplied by which the dimensions will be reduced. Okay, so how will I use this information? Well, you can draw a sketch of each of the triangles. And calculate the areas of each of them. Then you can look for patterns. In your results. I should say the results. All right. So first one, here's our first triangle. Well, actually the first one is This is 6, and this is 16. So I'm just copying this one over again right here. So if I multiply 6 by a half, I end up with 3. So it's only going to be 3 centimeters tall now. 16 multiplied by 1/2 is 8. So now I can figure out the area. Area equals 1/2. Let's see, that would be 3 times 8, which equals, well, half of 8 is 4. So 3 times 4 is 12 centimeters squared. Sorry, I didn't do this one. So we have 6 and 16. Whoops. Sorry. I already put the 16 in for me. All right, so half of 16 is 8. 8 times 6 is 48 centimeters squared. So look at that, it's already more than half. It's 4 times smaller, isn't it? Okay, and last one. Let's sketch. I have, so this would be what, 1/4 was the last one? So 6 times, 6 divided by 4 is, okay, let's do some margin work. 4 goes into 6 one time with 2 left over. So it's 1.5. So this is 1.5 centimeters tall. And then, what is this, 16 times 1/4, or 16 divided by 4 would be 4 centimeters. These are all centimeters. Okay, so let's see what that does to our dimensions. Area equals 1/2 base times height. I should write out the formula first. Area equals 4 times 1.5. So half of 4 is 2. 2 times 1.5 is 3. And that would be centimeters squared. So notice, wow. So, what would that be? So, how much smaller is that? 1. So 16 times smaller. I should do all the math for you. Okay, so this is 16 times smaller. When I multiply it by, the area is, this area is 16 times smaller when I multiply the dimensions by a 1/4, or reduce by 1/4. So when the dimensions are multiplied by a half, the area is 4 times smaller, or multiplied by 1/4. When the dimensions are multiplied by 1/4, the area is multiplied by 1/16. It's 16 times smaller. Make that look like a 6. All right, there are no notes with this lesson. Good luck with your PMT.